Will Titan become habitable when the sun expands? What's the next target for the Event Horizon Telescope? Could we see light from the sun's past? And in Q&A Plus, a quick update on the search for Planet 9. All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Overall opposites. Can we use light bending around a black hole as a time mirror to see the sun in the past? Theoretically, yes. Practically, no. So, the first part, does light bend around a black hole? And the answer is, yeah, theoretically. In fact, when you look at these sort of artist illustrations, these mock-ups of what a black hole looks like, you're seeing light that is wrapping around the black hole from all angles. And so you sort of imagine as you get closer and closer to the black hole, your light is just going to all go in. Like once you cross the event horizon, all light goes in. But just outside the event horizon, there's another region called the photon ring. And this is a region where theoretically light can be in orbit around the black hole. But, the way the direction of the photons come in, they're not going to be in these sort of perfect circles. They're going to do loops around the black hole and then go back out in some other direction. And theoretically, there will be photons that have been emitted from the sun. They've gone all the way to a black hole. They happen to hit perfectly at the right angle into an area that's around the photon ring. And they come around the black hole and then they're emitted in exactly the opposite direction. And so the black hole acts like a mirror for the photons that are coming from the sun. So that's the theoretically part. The practically part is you've got to imagine sort of the numbers here, right? That you've got the sun. It's trying to go to a black hole that could be thousands, tens of thousands, millions of light years away. Like how far in the past do you want to be able to see the sun? You want to see dinosaurs? You're looking at a black hole that is going to be 65 million light years away. So that the light is 65 million years ago. And then you got to wait for the return journey of the light. But practically, the number of photons that have gone all the way to this black hole that is that far away is almost none. But then the number that is made a perfect 180-degree turn around the black hole and come back to us is none, right? Like every now and then it happens, but you've got to be ready for that one photon. And you don't get to really make a sort of a comprehensive view of a dinosaur with one photon. So theoretically, yes. Practically, no. Draw Ural. Do we know where the habitable zone will migrate to when the sun gets hotter? Will Titan become habitable? So the sun has a limited lifespan. It's going to live for merely another, 5 to 7 billion years. As it continues to age, it's going to get a little bit hotter. It's going to get hotter in about 1 billion years so that it boils the oceans on the Earth. But it's really going to change its temperature when it reaches the end of its life, when it's used up all of the available hydrogen in its core. It's turned all the hydrogen into helium in its core. It switches to helium burning, and that kind of changes the characteristics of the star. It gets into its sort of end of life, and it will bloat up as a red giant, and it will consume Mercury, Venus, maybe consume the Earth. The science is uncertain. And sometimes people say it's going to eat the Earth. Others say it won't eat the Earth. Who knows? But the habitable zone around the sun will absolutely change. It will extend outward. And one of the things that is going to happen is that Jupiter will go into the habitable zone. So the large ice moons around Jupiter will melt. And so you'll get a liquid ocean on the surface of Europa and Ganymede and Callisto. Io will still be just a volcanic hell. So briefly, for a few 100 million years, those moons will be in the habitable zone, which will be really interesting. Now, it won't be a sort of a great life, and you're going to get these really big fluctuations in temperature output coming from the sun. They often, when they get into this red giant phase, they'll go through these cycles. They'll bloat up. Then they'll sort of reach a new equilibrium, and then they'll collapse back down, and then they'll blow it up again. And each time they do this, they will sort of shed this shell of material that goes off into space. So it won't be sort of like a nice dependable water world that you can live on, but it will definitely change the situation. But I don't think it's going to go all the way out to Saturn. Saturn is much farther away from the sun than Jupiter is. So my understanding is that Jupiter's moons will melt, but not necessarily Saturn's. But it will get warmer for sure that far out. Orion Spur. Shouldn't we pray there's no life on the moons of Saturn? We're going to need those resources to survive long term in this solar system. I think that's an interesting question. This sort of comes down to what are the ethical issues of us using the material in the solar system matched against what is interesting scientifically for us to find in the solar system. And so there are these places in the solar system where there might be life, right? Under the ground on Mars, under the surface in Europa, Enceladus, other icy moons in the solar system, and that, our future space exploration plans are going to require water, and lots of it. Water is fuel that you can split the water, use the hydrogen, use the oxygen. Like, there's going to be all these reasons why you're going to need access to those resources. And that, human life, we're going to be bringing our life with us that is going to infect the surface of these planets. That, if we do at scale start to mine the surface of Europa for its water, who knows? We'll probably never get to this place where we've, destroyed Europa entirely for our swimming pools on Ganymede. But who knows, right? Like, exponential growth takes you into funny places. And I think that we live in this moment right now where we don't know the state of life in the solar system. There are two possibilities. One is there is no life, that the only place where there's life in the solar system is Earth. And so the rest of the solar system is just raw material, right? Like even here on Earth, right? If you drink a glass of water, you are drinking life. And you're like, oh, should you be concerned about the life forms that you're drinking? No, because the water's going to make more. Don't worry, there's plenty of life filling all the water that we drink, and there will be more when you drink it. But on a place like Europa or Enceladus, as soon as we arrive, we're going to be covered in our filthy bacteria, and we're going to potentially infect those planets and replace the life forms with Earth life, obscuring the answer to that question. And so do we have an ethical question on whether or not we should do that or not? And then you have that deeper question, which is just like, if there is no life there, then that stuff is just raw material, right? Should you feel sad about destroying Europa? Well, yeah, because it is beautiful. And there's like these sort of ethical reasons, aesthetic reasons why you wouldn't want to tear apart Europa. And also it's a gravity well, and gravity wells are for suckers. So instead of tearing apart Europa, tear apart a comet. Tear apart an asteroid. Those things have no gravity well, pretty much, and still have tons of resources that we can use. Maybe down the road, when we've torn apart all of the comets, all of the asteroids, we're starting to look over at Europa and Enceladus and go, should we start working on those now? But that will be an extremely advanced society, something that is sort of not understandable from our sort of current civilization, and we'll let that figure it out. But I think, there is a really good argument that there are places in the solar system that are worth preserving purely for their existence as a wilderness and their potential for life. Mars is one, Venus is another, the large icy moons of Jupiter and Saturn are others. There are places that should be considered wildernesses in the way that we have places that are considered wildernesses here. Mountains, forests, oceans, archipelagos, really interesting places. And that there's so much raw material out there in the solar system. Why do we need to tear up Mars, when we could just kind of leave it for a while and enjoy Valles Marineris and enjoy Olympus Mons and enjoy all of the weird terrain and the ice caps on Mars? Because again, it's a gravity well. You're going to have to go down there. You're going to have to pay a huge expense to go down to the gravity well and come back out. So we'll find out. But if I sort of know human tendency, we're just going to use it all up, whether there's life in it or not. It's time to shout out our new patrons at the $5 level and above. Phil Bergen, Daniel Michael, Fishoid, Kelly Elizabeth, Keith Blix, Peter Scott, Julian Vincent, Luis Souza, Tim Rhodes, and Whiskey Flynn. Join our community at patreon.com/universe today. Adam Redwine, what's the next target for the group that imaged the two black holes? So more images of those same black holes. The problem is that the Event Horizon Telescope, which imaged both the black hole at the heart of M87, as well as the supermassive black hole at the middle of the Milky Way. Those are the largest black holes that are available to be imaged. And in fact, they're kind of roughly the same size in the sky. Even though they're dramatically different distances, it's that the one in M87 is gigantic, while the one in the Milky Way is smaller. It's just that visually on the sky, they are about the same size. And that there are no other black holes that are kind of within striking distance of the Event Horizon Telescope to make the same kind of image. Now, there are other observations, and there was actually a paper that we reported on just a couple of months ago that they're looking at the larger environments around other black holes, looking at the magnetic fields and the way they interact with their environments, but you're not seeing that shadow of the Event Horizon in the way that you did with M87 and Sag A-star. So what do? Well, the problem is that we're out of Earth, right? Like the Event Horizon Telescope is already the size of planet Earth. And so we can't put more telescopes to make that interferometer, the baseline, any larger. To make it a better telescope, we have to go to space. We've got to add telescopes to the Event Horizon Telescope that are now on the moon or at one of the Lagrange points. And so then you're getting a baseline that is hundreds of thousands of kilometers, potentially millions of kilometers across. That gives you the new resolution, allows you to look at other black holes. And, I've reported on this quite a bit and interviewed people. There was a radio telescope or like a radio instrument that was orbiting a geostationary satellite or like at one of the L Lagrange points. And so it was able to provide a bigger baseline. They were able to make sort of proof of concept that you can combine the observations from ground-based telescopes with a space-based telescope, and you can have that interferometer experience. But right now, there are no solid plans. There was another paper that I reported on sort of talking about what targets you get, and you get dozens, right? Dozens, if not hundreds of supermassive black holes suddenly become observable, that the observations that you get to make of Sag A-star and M87 star go up. You get closer to the event horizon. So there's a ton of really important, really useful reasons why you would start to extend the Event Horizon Telescope out into space. And the cool thing about radio telescopes, right? Like the Event Horizon Telescope is not a telescope. It is a party, right? Where a bunch of different telescopes all together agree to make similar observations on the same object for a certain duration of time. And then when they're done, they gather up all their data, they send it to a central place for processing, and then the telescopes turn and they do their normal jobs. They look at other stuff. And so the same thing, you could launch a radio telescope into space, and it could make observations as part of the Event Horizon Telescope, send all those data back home. They could be crunched together in one place, and then that telescope would then go on its work as a radio telescope in space. The problem with radio telescopes is they work really well on the surface of the Earth, that there are these gaps in the atmosphere, not physical gaps, but sort of like wavelength gaps that various kinds of radiation are able to pass through. One of those obviously is visible light, right? We can see stars, we can see the sun, we can see out into space because visible light can pass through the atmosphere of the Earth. It is obscured by clouds. They do not pass through clouds, but it does get through the atmosphere. Radio waves go through clouds. And so you can have a radio telescope during the day doing its work, looking through clouds to some extent, and be able to make observations. So there's a lot of reasons why you just build your radio telescopes on Earth. So you're going to need something like this. Like, let's extend the Event Horizon Telescope. Let's build a custom-built, really cool radio telescope out in space. There are other advantages as well, but it just hasn't been a gigantic, huge priority. But we're getting to this place where the astronomers are continuing to map out the magnetic fields around M87, the polarization of the light coming from M87, trying to get a sense, maybe a hint of the photon ring, or like it's just continued observations of these targets because that's all that's large in the sky. Mark Von Steen. Fraser, if you need to shadow ban people to support your ideas, are they really ideas worth having? So I've never shadow banned anybody. Not ever. I have banned people, but they know they got banned. So I've never done shadow banning. Now, that said, YouTube does do shadow banning. So YouTube has a bunch of policies that are going to prevent people from posting stuff. And, their policies and their algorithms change all the time. One of them is to not put links into your posts. Like that is the way that spammers attempt to control spaces and market their stuff, is to put links into things. And so YouTube is very strict about putting links into things. Generally, pretty much I'm the only person who could put links into comments on my channel. Regular posters are not able to do that because YouTube frowns on it. Now, if I'm sort of like, I've got time on my hands and I go into the held section of YouTube and I look through the comments and I see someone who was very helpfully providing a useful reference to some story and it was held by YouTube, then I might approve a bunch of them, but I have to think of it and YouTube doesn't put it in my face. And I don't know how many posts have been held. So that's sort of that's automatic. Like if you're going to put links into your posts, just assume that nobody is ever going to see them, right? Or into your comments. But then YouTube has a whole bunch of other stuff that they're looking for. They're looking for language. They're looking for tone. They're looking for things that people might say where they've said the same thing on a lot of other channels, right? Because again, these are the hallmarks of people who are spamming things, or the hallmarks of people who are trying to kind of degrade the conversation across all of YouTube. And just like by default, you just kind of let all this stuff run because in general, it works pretty well. So, my advice to you is just like tone it down, settle down. Like I'm guessing based on the hostility of your comment to me, right? Your assumption that I'm shadow banning you, then you've got something to say that you feel like the mainstream media and me as a member of the mainstream media, as the established space community, doesn't believe in or doesn't approve of. And that's not true. I don't get my checks from NASA. I'm just a journalist. I am definitely err on the side of the scientific consensus. I err on the side of expertise from scientists, but I'm not using my platform to discredit other stuff. I'm using my platform to amplify the kind of news that I think is important for my readers to see. And if you haven't gone through the standard channels of getting your work published in an established journal, getting it peer reviewed by other scientists, I'm probably not going to report on it. And I'm probably, not going to go out of my way to make sure that your voice is heard. So instead of sort of like whatever, I'm not sure what you were saying. I'm not sure, because again, YouTube hides a bunch of this stuff from me, so I don't know. But I'm, based on your attitude, just based on what you said, I'm going to assume that it's the kind of thing that if I looked at it, I'll go, oh yeah, I get why YouTube has been sort of turning the volume down on what you're saying. So instead, just join the community, be open-minded, ask questions about space and astronomy. Just get to know us as opposed to coming in hot. That's my advice to you. Or don't, whatever, I'm not your dad. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. In this week's bonus question, I give a quick update on the search for Planet 9, and I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank everyone who joined me for the live show. Ask your questions. That becomes the raw material for this episode. Our next live show is going to be happening on Monday, January 4th at 10 p.m. Pacific time, which is set so that it's good. It's evening, early evening for people in Asia, Australia, Japan, that part of the world. But of course, people around the world can watch it at different times as well. So there'll be an event here on the channel. You can go and, set a reminder if you actually want to join me, especially you Australians. We're doing this for you. Now, I'm going to give thanks to my editor, but first I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balak, Cy Nelson, Dark Finga, David Giltonen, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Sitz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Roebuck, Rankaidu, Richard Williams, Sean Sargent, Team Filer Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldemort Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So here we go. This is the last episode that we are releasing in 2025. We've got more stuff going to be releasing on January 1st, but this is the last episode before the end of the year. And I would like to give a huge thank you to the editor, Chad. Weber, who has been there and edited every single question show since its inception. And I'm sure Chad has a number for the number of episodes that he has edited so far, but it is definitely in the 500, 600s more plus of just like total videos here on the channel, and has been going for like, Chad is going to have to like write numbers on the screen because I don't remember when he started working with me on this channel, and yet has been here for an enormous amount of time. And he is so fast and so good and so careful. You know, I make mistakes. He can tell when I am uncertain about giving an answer and will jump in and double check, and he'll confirm with me, and we'll come up with a way to fix my mistake or remove it or whatever. And it's pretty amazing. He is very disciplined about making sure that we know exactly where every piece of media came from. He does not allow any sloppiness on that regard, and make sure that, you know, we are giving proper credit to everyone whose images and stuff we are using, and that we have the right to do so. So I appreciate his diligence and his skill and his speed and his sort of thoughtfulness and just his overall skill as an editor, and just like what a great person he is to work with. And now I am giving him the uncomfortable job of editing a video where I say nice things about him. So Chad, thank you so much for continuing to be part of this journey with me for another year, being the video editor for the question shows. You do an amazing job, and I hope we just do this forever. All right. And then for those of you watching this, we'll see you all next year.